Good morning, everybody. Welcome to these sessions. I think that today Grenzoback would like to show what they are doing now in the hot end. My name is Robert Lamy. I come from the annealing glass world, so I'm in contact with this process since more than 23 years. And I'm very happy to introduce you Marcus Michels, who will take soon the lead of the hot end at Grenzoback, because soon I will take very long holiday. So this is and I'm pretty sure that you will be more than happy to work with Marcus Michels. So today, what we have prepared for the agenda, it's to maybe take more time to discuss about the annealing layer, because over 23 years, I receive a lot of remarks, comments from the customer. Yes, but all the layer looks the same. What are the innovations? Some innovations are just only outside, let's say, the equipment. And when I joined with some colleagues at the Grenzoback organizations, Grenzoback gave us a signal that they want really to develop the business and to continue, let's say, the activity in the hot end. Hot end, we start also from the bath and the annealing layer. And what we did all together with a team is to review what are the main fundamental questions that we receive from the glass industry. First, what is important when we talk about an annealing layer, it's not really the equipment, it's more the process. Because when the glass just enter in the layer, the glassmaker already spent all of its money in the energy consumptions. And the purpose of a layer is to keep the ribbon in one pieces and to delight our colleagues from the cold end. So in terms of the reflections we had, process that is very critical. Secondly, about equipment, I think that today there is a target in the whole industry is to reduce the carbon footprint. So any small saving in terms of energy consumption becomes important, because today the industry takes the sum of all the small saving. A few years ago, when we came with this approach, people say, yeah, but layer it's not a priority because we can generate much more saving at the level of the furnace. Today, everything changed, because all main part of the float line need to bring its contributions. And for that, Grenzoback spend a lot of time. Another topics that we develop is maintenance of the equipment. Today, when you walk along an annealing layer, you see heavy equipment, hot air fans, control valve. And for the maintenance, it's not easy to work. You need also to spend a lot of money in walkways, crossover bridge. And I think that what Marcus will present, a lot of extra costs will disappear. Energy consumption, I mentioned, the safety, maintenance, I think it's important. And for the process later, we will show the flexibility that the new design for the Grenzoback annealing layer will bring to the glass maker. So, Marcus, yeah. I leave you.
So, maybe first we show you here some picture. You see, this is the new style of Lear, the Grenzoback annealing layer, and as you see, it's different, totally different looking. You not even have the big fans on the top, so not your big fan with the platforms, as Robert mentioned, and your control valves where you control the system. You have now very small fans, which are driven by inverters. So you control your process now by inverter. You have much more flexibility to have, so you can much better control. It's more flexibility. You have your annealing zone, which you can shift easily, so it's not linked to the fan, which is running all the time with full power. You can easily control. And also you have now your adjustable edge heaters in top and bottom. That is now also an advantage. Before it was only available in the top. Now we have it in the top and bottom to have more flexibility. Then we have our heating drawers, top and bottom. And also a very big difference is now our control zones are only 6 meter or 12 meter. So we are not anymore with 27, 30 meter control zone. We have small control zones, which make it much easier to control and adjust. And also a very big change is our small fans we now have are blowing fans. So we not anymore suck the hot air. So now we have cold air fans which are blowing. And why can we blow? Because we have a new design of the heat exchanger which are 100% Titan, so they are welded. And we know what is the expansion of that smaller heat exchanger, so we can calculate, and we don't have anymore the sealing inside. So there is no risk to blow air inside. And if we have a 12 meter section, we connect on the top of the Lear. So that means there will be no risk to blow some air inside. So it's a very safe process. Then also this small fans which we install in the tunnel are only 250 to 370 watt. So instead of the very big fans with 15 kilowatt, 20 kilowatt, we have very small fans. You can easily put by hand. Then we have also less noise level, I think, which comes important for the customers. So we are now less than 80 dBA in the zones ABC. So that is also a very big advantage. And yeah, maybe go to the next slide. So here you can see again, so for the access of the blowing fans, it's now much more easy. You don't have to go on the hot area where you stay at 70 degrees. You can come from the side for the zone red. You come from the side, put your fans, and can change the fans. So it's maybe also here you can see, so this is the zone ABC. So there is the zones where we use this small fans. As you can see here, these fans are really maybe 2 kilograms. You can easily put it by hand and put a new one. So even if there is some fan broken, you don't have to think about how can I repair or how do we handle that. You put a new one. So you have some on stock. You go there, you will see in your DCS which one is the damaged one. It will be red. You go there, put a new fan on top, and then you put a new one in your stock. So, sorry?
So you said five fans per zone for the top and the bottom? Or?
Yes, so we have, in general, we have 6 control zones, top and bottom. But for sure, we can also have only 5 on the top, so we connect the middle one. That is also a possibility. It depends on what the customer wants to produce. So if we have only 5 control zones on the top, 2 fans in the middle will be on one inverter. Otherwise, every fan has an own inverter. But it's also possible to have only 4 zones. So, but in general, we have 6. That is our basic configuration. And also for the bottom, you see the fans for the bottom are installed here on the side. This is the case because this new Lear can install on a slope, can install on a flat ground, or also if you have a basement. And if you have the basement, the small fans will be plugged from below in the Lear, but if you have a flat floor, you have the fans on the side for the bottom. And here we have some picture to compare. That is the standard design, you know, with the big fan, with the piping, with your walkways, which is very massive and big, and also a lot of money for the walkways and everything. And with the new design, it's very compact. It's much more flat on the top. You can see it's really, if you see the Lear, it's not anymore a very big thing, not anymore very heavy equipment. It's now everything is smaller, lighter equipment. That was our goal we want to have. And what is also all the time, let's say, a point which Grenzebach think about to change is the shipment cost, because we know with the old design we had our Lear sections which are assembled in our manufacturing and then we ship to you. So you need flat rack container which were very expensive. You have to put on the top of the boat, and it's all the time a cost you have to calculate. And for that, Grenzebach developed a new system. So this new Lear is now done with kit assembly. So we call it kit assembly. That means we deliver all the parts separately in normal oversea containers, 50 feet containers. And then you assemble like that. You put your bottom floor, then you put your bottom heat exchanger in, then you put your sidewalls. Then we have some helping tools for putting the top heat exchangers in, and then you close it like you put your top on. It's like a box, so you can, everything is like a kit. And then at the end you put your fans on the top, your collector box for the exhaust. So we collect all the exhaust air here, for example, and then the customer can connect to his warehouse, or he wants to go outside or go in the building. So you have still these opportunities, but this is really an advantage that we now can ship everything in small containers. It's much easier and it's more standardized. So, and also a benefit, so we have already a prototype, it's not only a scratch. So in our site in Germany, we have already a prototype and we spend a lot of time to test everything, hot tests, or also the assembly. And as you can see here, we go to the other side. So now the sidewalls are clamped. It's not anymore, we have an inner casing and an outer casing as in the old system. Now our sidewall plates are clamped. And that means we can use for the insulation plates, not anymore the bulk material which we have to put in. And you have sometimes some problem with the insulation, or the insulation is not everywhere, it's not, you have not the right pressure on the insulation. And now with this system, we have our plates in and we have a fixed pressure on the insulation and we are much more insulated. Everything we can better calculate and is for sure better for the whole process. And here you can see on the left side our heat exchangers, which are now the 6-meter ones, which are 100% welded in a special design to have the expansion. Then maybe come to the zone red. So also in the zone red we have a change. It's not anymore the big fan. We have now also 6 fans in the zone red, and these 6 fans, so also 6 control zones, top and bottom. And these fans have some damper to mix the air, because in the zone red we have to mix the air, as you know, and now we control also with inverter. So the complete new Lear is everything driven by inverter, so you have the most flexibility you can have. And the same for the zone F, it's also driven by, we have 6 motor fans driven by inverter and also 6 control zones, top and bottom. And what is also now a thing we developed, it's an automatically lift up system. So that means if you have some glass breakage, we have a sensor and then the nozzles are going up. Because we mentioned some of our customers have problems with glass breakage and then the nozzles are bended and you have not anymore the right cooling. So this system is done with a pneumatic cylinder. So that means even if you have no energy or the pneumatic is not working, you can lift it up. There are push buttons to lift it, or with the sensors there is automatic lift up. So that is for safety reasons and to, let's say, not damage the material. And also you can adjust with this system the height of your nozzles. So if you produce thicker glass, you can adjust. If you have very thin glass, you can also adjust. Also one, say, change from the known Lear is in the zone D to F. So there we have only the, I say, light rollers. The rollers with the donuts, not the heavy steel rollers, which are 305mm steel. And for that, we are thinking the normal driving mechanism is too heavy, because you don't need it. It's very small rollers, it's easy rollers. And for that, we introduced in the zone D to F our driving mechanism from the cutting line, which is very well known and is working well. There we have a servo motor, a gearbox, and then our bevel gears. And that also reduces a lot the maintenance on site, because here you only have to grease it, so you have no oil, it's only grease. And it's much easier to change these motors. It's small motors, you have different control zones, and also you have less spare parts. So you can use the spare parts from your cutting line also in your annealing Lear in the last zones. So that means for you as the end user, it's save you money in the spare parts. And it's easier to change because everything of the shaft and everything is very light equipment, so not the heavy equipment. But for the zone A to C, we stay with our well-known and well-introduced driving mechanism, because we think this is the critical part where we want to be sure that it works. Then maybe something about the control system. So in general, our control system for the new Lear is split in 3 parts. We have our heating, our cooling, and our drives. Our heating system is working with thyristor controller and PLC. For the cooling, we have our frequency controller to control our fans and the PLC. And for the drive, we have our drive and the PLC. And all these 3 splitted parts are connected to the system network. And from this network, you can connect to your DSC, to the HMIs, or to the PLC. So that is, let's say, here is the connection point where we can connect everything. And also you can have remote access, so Grenzebach can have remote access if the customer wants. So that means you call us. If you have some problem or you want to adjust something you don't know how, you can call us. We can come on your line and we adjust it from our side. So it's more service flexibility and we can support you better. And now we come to some case study, as Robert mentioned, and I think he can explain well
Okay.
the
So
study.
now regarding the process, the new design, we will not reduce the length of the equipment. So the fundamentals remain exactly the same. Because for the stress in the glass, you need to respect some fundamentals in terms of a cooling rate linked to the speed, the resident time of the glass when the glass crosses the zone. So there is, I would say, no change in the concept. The tool that we are using is different. And Marcus highlighted the benefit. But now I'd like to take an example where, and we see that more and more, that people like to have flexible equipment, especially at the level of the Lear, because sometimes people have to reduce a lot the pull, depending the type of the productions. And nowadays there is a trend for architectural glass, but also for automotive glass, to try to produce thinner glass. There is a race to deliver light product, also for architectural application. But when we start to produce thinner glass, high tonnage, the bottleneck, I will say, will come from the thin bath, because if the speed of your ribbon is too high, you start to take some thin particles on the glass. And nowadays, we put more and more electronics on the glass. So the defect that were accepted 5 years ago, today they are not anymore accepted. So this is why sometimes we have a case where the customer have to reduce the pull by nearly 50%. So at maximum tonnage, I would say we have this annealing area. So for the annealing area, we start between 540 to 480 Celsius degrees, not Fahrenheit. But when you start to reduce really the load and you want to keep this same profile, you start to bring a lot of energy, because the glass will tend to cool too fast because it doesn't bring enough energy in the system. So why to spend money to maintain the glass and temperature when we know that if we reduce the load, we can start earlier the annealing process? Because at the beginning, above 540, you can cool very fast the glass. You will not hurt. You will never generate a stress. But where we have to limit, it's in the annealing area. So, and here we can see the benefit that we can reduce the zone. So, and the remaining part can work in idle mode. So again, also some benefit to limit the energy consumption. So here, one benefit is to limit the installed power in the critical area of the Lear. So that is one of the advantage. So the next one, okay. I think that is what is more important. It's what are the figures. So Marcus mentioned, okay, typically we have 5 controls on top of a bottom. We can have 6. It doesn't, let's say, generate cost because we are using small fans. But I think what is important for you, glassmaker, it's that, so today, with the new design, we can reduce the installed power for the cooling by 50%. And I would say for standard applications, like architectural glass production, you control your process only with the cooling. The heating is just for the heating up. You need and to compensate some heat loss, no. So here, this is now the use power per ton. If you go in the file of, I would say, the standard design that came from Knut and the old contract, the guaranteed value on the energy consumption was 15 years ago 10 kilowatt hour per ton. So, and today we can drop to 3.5. So over 20 years, I think that you can generate some benefit anyway, or to spend some money to other area. Noise level, I think that noise level is critical. Some countries are very tough legislations, like Brazil, in UK, and people try to now to be lower than 80 dBA. But when you are working with a big fans, hot air fans, a way to reduce the noise, it's also to limit the speed, and you start to invest a lot. Or you put your fans outside the building in a special room. But again, it's an extra cost. Shipping, Marcus mentioned it, with the kit assembly. The word of open top disappear. So if now you are thinking to have a very wide layer, I would say, normally we can put only one section on a flat rack. And during the COVID, the cost of a container, a flat, reached about $20,000 US. So now it's better. So, and also having the possibility to ship all the goods in dry container, you limit the risk also of a moisture, because on the flat you are on the top of the boat, and you cannot. Yeah.
So I'd like to ask a question about lead time. So current process, build a long line, you ship it, it gets commissioned. Now you're going to make units,
Okay.
ship it, and probably reassemble them again. So is there a manufacturing lead time?
I would say regarding the fabrication time, I think that we will probably stay maybe close to what we have, because we will have also to put more attention on the packaging and on the logistic. So maybe there will be some benefit, but we cannot say that we reduce by 20% the lead time. What is true is now we come on your side, and we will increase the supervision time about 30%, because that you have to assemble on the site. So what is important is to discuss the planning of the execution of the installations with the customer. And today, instead to wait the last 4 months before to start the Lear, maybe the best is to start the installation 6 months prior to furnace heating up. Okay? So advantage on the shipping cost, and I think that maintenance, when you look the sketch or the prototype, you have a very easy access to the equipment. We are talking about small fans, maybe 1 kilo, no more. What else you have on the top of the Lear? It's thermocouple, canalise bus bar, or electrical cabinet for the connections. That's all. Today, when you see the assembly with the hot air fans, you have a specific area where you have a lot of equipment, high density, but also people do not have too much space to work. So I think that the safety aspect is also critical and offer a lot of benefit. And for the spare parts, I would say we have 2 types of fans for the tunnel and 1 type of fans for red NF. Today, if you look the standard design, all the control valves do not have the same diameter. Because control valve, you have a regime for the control between 30 to 70% opening. Below or above, it doesn't work. But here, we reduce a lot the number of spare parts. So you reduce your capex, which is not good for a supplier. We prefer that the people purchase more spare parts. So that is, I would say, the main highlight of this new concept. Again, the principle remains the same. And the reason why we can blow air, it's because we have a tight heat exchanger. Instead to have one fixed point with one expansion in one direction, we have a fixed point in the middle and we allow the expansion on both sides. So we can limit. With today, the standard design, can we blow air? I would say it's risky because you have too many joints between the heat exchanger. At the end of the year, people use a lot of SO2, and at the end of the campaign, some joints disappear. So if you blow air, the air will go through the tunnel and you will influence your process. Yeah?
Your edge heaters, you talked about adjustable.
Yeah.
Are they motorized, remote controlled, or?
I would say today it's not, normally it's manual. I would say this is something that can be all the time studied. But what I would suggest is how often do you have to bring the heater at the right positions? So if it's only for 5% of your production during the year because you produce a narrow ribbon, in terms of capex, I would say it's better to have a manual one. We can put a rule, and people can know by how many persons you introduce the movable heater inside the casing. Okay. So I don't know if, and here is another example with a float line of 1,000 tons per day, where we have also the small control zone, and we can have a better linear cooling. But
Are these in production now, or are you still?
today, let's say this development started 2.5 years. So from a white page, a lot of scientists were involved. After the pilot test, all the tests confirmed the feasibility. And today we start now to quote the new project. So what we show, it's a real project. Yeah. I do not disclose the name, but we start to. And so far, I would say, and I hope it's the same for you, we start to have a good feedback. But it's important to receive also the feedback from a customer, because if a supplier can improve itself, it's because it receives also some feedback from its customer. It's a teamwork, I would say.
And is it going to have both DC and pyro control? Or is it
For the control, I would say it can be à la carte. Well, today, the majority of the equipment use thermocouple. When we look how the industry, where the industry likes to go to 4.0, you can install scanning parameter. In an open zone, you can put also thermal camera, because people would like to collect more precise information. The difference between a scanning parameter or optical parameter versus a thermocouple is the optical parameter measure the glass temperature, and a thermocouple just measure the ambient air above the glass. So you have all the time a difference in reading between thermocouple and optical parameter or scanning parameter. But the Grenzerbeck Lear allow to implement new equipment for control. And also, with the new Lear, Grenzerbeck can offer the full package, not just to limit to the heating power cabinet for cooling and heating, or for the speed variation system. Now we can go to the DCS. And the Grenzerbeck are working also on the Cerisy?
Cerisy, yeah.
So to collect data, and the purpose is after to treat the data. So you have an equipment that is really prepared for future development in terms of data collection.
So you're talking about the heating controller as well?
Yeah. today, with the standard, we just provide the signal. So a lot of cabling and so on. Tomorrow, you can sleep well. Everything will be taken by one company. And by offering the cold end and the cutting line, you have one company that is responsible for the interface between the two parts.
That's scary too sometimes.
No?
Everything in one company.
I would say it depends. I think that Grenzebach is a well-known company. And when you talk for a bigger package, I think that what can be scary is to be sure, is the company has enough financial strength? And it's the case for Grenzebach. Okay? So, no more question on the deal?
So on each section, how many rows?
The roller. Okay. There, again, the number of roller. I will prefer to talk about roller spacing. So it depends on your applications. For nowadays, for architectural glass productions, I'm talking about 600 to 1200 tons per day float line. You will have at the entrance of the Lear, till the end of the annealing zone, a roller spacing of 500 millimeter. And after, we will continue with a roller spacing of 600 millimeter. Now, for people who produce ultra-thin glass, and generally people try to produce a very wide ribbon, 5.4 meter, we will limit the roller spacing to 450 to better support the glass. But you will have to put also more attention on the quality of your driving mechanism, because the driving mechanism is very critical. It's not just to turn roller. The driving mechanism is a part of the forming process. Right. Because in the tin bath, you have the top roller machine. They do the lateral stretching, right, and the driving mechanism do the longitudinal stretching. So, and that, but with the new Grenzebach Lear, we can fix all the problem.
So on the section with the drive with the motor, is there redundancy for that? If that motor
Which one?
went out?
That is the
mean
must.
For this
Yes.
one?
Yes.
Yes,
If
there.
that motor goes out.
There is a clutch, so you have a clutch to the next shaft, so you
Okay.
can clutch.
Okay.
This
Yeah.
is then the next motor is the backup, and then you can restart again. There is
A backup is a must. It's a must. Okay.
Mhm. So,
Cool.
any more questions to the Lear or
Control the mass air section. What is that?
of what? Sorry.
The mass, it's the zone.
D through F. Yeah.
Okay, so when we start from, let's say, D, red and F, we are using the convection process, because in the tunnel is radiations. There is no contact between air and the glass, it's through the tube. Now with the convection process, we blow air, and in the zone red, because the glass temperature will be still too high, we are close to 380 degrees. If you blow ambient air, if you want to produce cullet, do it. It will work. So that we have to preheat the air. But we will not use an electrical heater to preheat the air. So maybe you can show the picture? So here the fans take hot air from the inside of the zone, because the zone red is a closed zone. And we will allow ambient air. So generally the temperature of the air that you blow in the first zone red, depending on the production, can go up to 180 degrees. What is important is that the delta T between the glass and air that we blow exceed 200 degrees. We have to avoid thermal shock. So, and the advantage of this design, it's today we have manual damper that we fix at the startup, and generally people do not want to touch. But we noticed nowadays, due to the demand of the market about glass quality and so on, now some glass maker motorize the damper of the damper. But it's also a cost. Here you have small fans, and you control the flow by the speed of your fan. And the principle is exactly the same for the zone F, but we do not take the air from a closed area.
So if you wanted to, like in the mass air section, like what he's talking about, if you wanted to add more air to the center, then you would.
But you operate with the speed.
So each fan would be marked which fan would go.
It's like that.
where, and you would.
Yeah.
Yeah.
So
And
each fan has so there is a fan for the middle one, for the outer one, so you can control.
And for instance, if there is a coil repair and you increase the pull and we have no possibility to extend the leer, sometimes we have to be creative at the level of the mass air. Nowadays, what we try is to increase the cooling efficiency by the design of the blowing nozzle.
Right.
Over the years, there is a nice evolution. Sometimes we have to replace the old material and to put a new material having better performance. That it's really that can be integrated in your existing leer. Okay.
So then maybe we jump to the DROS box.
That I leave you.
Yeah. So also,
It's a teamwork. Huh?
so also one of our new developments, I would say, is in the area of the DROS box. So we shown this one on last year on the GlassTech, and we have there several, let's say, advantages we bring in. So first, we have our DROS box is not a welded one; it's also clamped one. So you have not a problem with, let's say, the deformation, and the DROS box is not anymore straight. Everything is clamped and can or have some area to play and can extend. So that is one of our advantages. Also, we have a special design to the U-channels to avoid that we have for the expansion some problems that we cannot lose anymore, and
We cannot damage the carbon.
to not damage the carbons. And our DROS box have a temperature range up to 850 degrees. So, and that we can do because we have a 100% insulated DROS box, which is very tight, and we have a special design for our carbon damper. So we use their pneumatic cylinders to have a fixed pressure against the roller to keep the atmosphere in the DROS box and not to have the atmosphere going back to the bath roof or going to the leer. So that is our special design. Also for the curtains, we have a special design to have a very tight DROS box and can go up to 850 degrees and have no problems. That is especially for the electronic glass. And also we can inject N2, so we have N2 pipes to inject. And also there it's very important to have a tight DROS box, that the carbon seals are very tight and your curtains are tight, because you don't want to have the N2 going all out. And our DROS box has a height adjustment system where you have not to open the ceiling. So we have a special ceiling system which is like a sliding system. And if you want to adjust the height of the lift-out rollers, you don't have to open any bolt. You only lift it up manually, or we have also automatic system to lift up. So that was what we shown last year. Then you have a control panel or a control box directly on the DROS box, and you are there and you can easily adjust the height without open any screw. So that is also a benefit. And you can also have it integrated in the DCS and then have some, let's say, resets for this production. I want to have this lift-out curve. For this production, I want to have this lift-out curve. Then you only press the bottom and the DROS box will automatically adjust the lift-out rollers to that height. And so
I would say that nowadays people put a lot of attention on the DROS box. In the past, okay, that was a transition between tin bath and the leer, and it should work. But when you start to have deformation of your DROS box, you start to damage your lift-out roller. To change a lift-out roller in production is never easy, and people like to avoid that. In the past, the DROS box were not insulated, so a lot of heat loss create also waving of your ribbon, so problem also of the quality. And the development of Grenzenbach, in fact, come from the glass, the electronic glass industry, because in this industry, people produce a lot of borosilicate glass for the TFT panel. So the viscosity is totally not the same than for soda lime. So, and due to the success and record of success in this industry, today we offer this technology for the standard float line. And since a few years, I have to say that we have customers that come back all the time for this design. Also for special applications like electronic or ultra-thin glass, this design allows also the installations of top and bottom heating elements. Reason is because we are working at a very low tonnage, and if you do not support the glass with some extra heat, the glass starts to cool into the Drossbox. And after you have a nightmare.
And also our design is available for ceramic roller or steel roller, maybe that we can also say. And our drive is not connected to the Drossbox, so we are not have no welding or no connection to the Drossbox. The drive is on a beam separately, so it's not directly connected.
What do you see about bearing protection or?
In the past, you have still a lot of Drossbox where the bearings are fixed on the side wall. That creates some difficulty. Here, the bearings are mounted on an external frame, so you are not close to the heat. And depending if you use a steel roller or ceramic roller, you can adjust the positions of this support, because with a ceramic roller, you depend, let's say, on the groove that fix the end caps on the ceramic tubes. And if the temperature close to the end caps, it's above 200 degrees, you lose the contact. So that is why you cannot have a deformations on the bearings, because we are outside the side wall of the Drossbox.
Are they far enough away? Do you need any kind of heat protection like water cooling? Or?
Yeah,
Those it's a water cool.
Yeah.
It's a water cool.
Mm-hmm.
Yeah.
What about the cover in terms of atmosphere containment?
So you mean the curtains, which?
Yeah.
Okay. So
I know it's not here, but it's part of the system.
so I think that we know that we have the curtains. Now what we do often is that the cooling of the exit lip, you can use water or nitrogen. We have design where we can combine the two. But if the people use nitrogen for the cooling of the exit lip, a part of the nitrogen can be blown inside the Drossbox, so we can create, I would say, a positive pressure to keep the atmosphere inside the tin bath. And for the curtains, what is important is how we fix the hood. In cold conditions, when you install a Drossbox and the hood, you have no problem to lift and drop the curtain. It works well, because you do the test in the workshop. But now, and generally when you fix the hood on the roof casing, during the heating up of the roof casing tend to do that. And what will happen? It will push on the hood of the Drossbox, and the risk is you have a deformations at the level of the curtains, and the curtains can be blocked. So that we have now a special fixing system where the hood can move with the expansions of the bath and the roof casing. And when everything is at the right temperature, we can seal the hood on the roof casing. But the hood is also important than the Drossbox itself.
Yeah. So.
Okay, that is my turn now.
Yeah, it's your turn.
Okay. So when we talk about tin bath roof, people perceive, and it's true, it's just an assembly of refractory, because that it's what we have to do above the glass ribbon. But what is important, and you can see an evolutions to different supplier, it's to limit the number of joints between, let's say, the refractory, because more joint you have, more chance that you have some tin volatile that will go through the joint. You will have some condensations, and when you have condensations, you have the tin drop on the glass ribbon. Tin drop means surface defect, and people like to avoid. And nowadays, what we have, we did some modifications in the design of the roof, on how to assemble the ceiling, the roof. And nowadays we come with these configurations where first we will limit the number of joints because we change the format of the rail tail of the rail. And big difference is now we are using only one hanger per refractory assembly for the rails. So the chrome nickel hanger is really inside the refractory and is not in contact with the heat and will be not in contact with the tin volatile. The standard, I would say, design is to have two hangers per assembly, but one hanger take a part of one block and the neighbor one. So the chrome nickel hanger is in contact with the heat, contact with the tin volatile, and if you have some peeling, naphthalene attack, with this design there is a risk that the block fall on the glass ribbon. That is something that people do not like to do because, but it happens. And to replace such a block in operations, it's possible, but it's also very dangerous actions because you need really to have a strong safety rules, because inside the tin bath you have a nasty atmosphere, nitrogen, and especially nitrogen. So that is, I would say, one advantage with this design. So this is how we assemble the rail. That is the face tile. Big advantage is we reduce the installation time. When you reduce the installation time, means that on your plant you will have also less people active. So you reduce also the risk of accident and so on. So that is, I would say, what we are doing with the bath roof.
Do you think that's going to impact the lamination?
That is different because that when you have a peeling, it's a chemical reactions. The chemical reactions will happen really in the hot area of the bath. So there is a solutions, and the solutions is to change the refractory material for the face tile, because the standard one you use it's a siliconite, and the one that resists better to the peeling it's the Calex material. That is only produced by DSF in the UK. So for Calex there is one single supplier that is recognized for this quality. So that we can offer both. But often the peeling depends also on the glass compositions. For instance, if you have a high iron content or low iron content, that can influence this chemical attack. So it's not the design on how we assemble. You have to select the right refractory material. And we have also additional equipment that we deliver for our customer, like the dedrossing pocket. We have Razorback has a design that improves versus what exists. So we are using the linear motor, but with the possibility also to move the linear motor inside the tin bath. Because some people, when they produce a wide ribbon, time to time they like to produce a narrow ribbon. So we have the possibility to locate the linear motor at the right positions. You can be sure that you create the stream and to get all the dross, and not to stay in a fixed positions. You have also the drossing paddle, dross box with the paddle, but I think that becomes really obsolete for the big float line. Twill mechanism, it's a design that it's well known. We have customers, they come back also to us. Well, what is critical for the twill mechanism is to have the good accuracy in the movement, because the flow of glass, molten glass that go to the bath depends on the good reactions of your mechanism. In terms of steel fabrications, well, we have Razorback, they have now the big factory in Romania. We can manufacture the bottom casing. Generally, the bottom casing that we manufacture are based on the drawings of the customer, because it's generally the glassmaker that make its own design for the bath roof. So we execute according to the drawings. Now the fabrication of bottom casing is also very, for the quality of the bottom casing is very critical, especially in terms of flatness, on the radius, because you bend the plate. Because if you are out of the specifications, the risk is after you put the blocking, you start to have a joint, and if you have a leak of tint, you can collect it in the basement because the tin will drill the carbon steel plate. So this is, I would say, what we would like it to present to you. For sure, there are other products that we can do and deliver for your new investments. But today, we would like it to take more time with this Grenzerbeck annealing mill.